The end of the school year left me feeling exhausted, so I headed up to UConn for some inspiration. I spent 6 weeks as part of the Joule Fellows program learning about engineering. In 1986, when I earned my degree in electrical engineering, there weren't many women in the field. By 2018, with the exception of computer science, not much had changed. But in 2021, things are different. At UConn, 50% of the biomedical engineering students are women, with many women also choosing civil and environmental engineering. UConn has 13 different engineering majors, including a multidisciplinary degree. 50% of Connecticut's engineers are UConn grads. We need more engineers, people like you. Are you creative with a love of math and science? Do you enjoy hands-on learning or have a passion for technology? Are you a problem solver? Do you like to help people and like the prospect of a high income? Consider a career in engineering. Are you that kid who played with blocks and Legos, always building things? Perhaps civil or environmental engineering is in your future. Maybe it's time to trade in the blocks and Legos for high-strength concrete. Can you picture yourself designing major transportation projects or systems for clean water? Do you like to tinker with circuits? Whether your interest is nanoelectronics, devices and gadgets, or even the major infrastructure of power stations and military defense systems, perhaps you should consider electrical engineering. Do you like working with machinery? Mechanical engineering is a broad field that goes beyond manufacturing for the aerospace and automotive industries. Perhaps you will design the next Iron Man suit. Do you enjoy gaming or find robots fascinating? Both the gaming and manufacturing automation industries have a high demand for robotics engineers. Whether you major in engineering or some other field you are passionate about, I challenge you to be more involved in your own education. And most of all, I want you to believe in yourself. It all starts with a question. There are over 40,000 people at UConn, but where does all the wastewater go? Thanks to chemical and environmental engineers, they reclaim millions of gallons of water. Do you ever wonder how automotive manufacturers choose a vehicle's materials inside and out? The automotive industry is learning critical features of materials from microscopic images. This helps them predict material behaviors and guides them on choosing materials to optimize design. At UConn's Innovation Partnership Building, some researchers use transmission electron microscopes to see the individual atoms in materials. At the Institute of Materials Science, they are asking questions like, what if a material can change shape according to temperature, like from two-dimensional to three-dimensional? Or how can a material change colors to mimic life? Or how can we design soft, flexible grippers for robots and other medical devices? The Civil Engineering Department is working with the National Science Foundation to research the question, what if we use the strengths of neurodiverse students to drive innovation? In one biomedical engineering lab, researchers are asking, what happens when the cartilage in your knee has worn away? Can we find a way to repair it and eliminate chronic pain? I really want to delve more into the opportunities a career in biomedical engineering has to offer. But first, a career I never knew existed, bioinformatics. I spent a week learning about bioinformatics, which is all about using computer science to understand life, like how to write an algorithm to optimally align gene sequences. So if you are torn between science and computer science, why not keep both and choose bioinformatics? I spent 5 weeks working with graduate students and my lab partner, Ashley LePayne, in the biomedical engineering lab. Our first project was a wireless Bluetooth smart bandage and smartphone app to help diabetic patients minimize the pressure on their foot ulcers. We had plenty of hands-on experience, from laser cutting printed circuit boards to soldering components so tiny you needed a microscope. We assembled and tested both sensors and Bluetooth modules. The best part was the product testing, where I felt like I was the Cinderella of the biosensors lab. Our second project was an RF antenna for optogenetics research. Optogenetics is a biological technique that involves using small LEDs to control neurons. We helped test various antenna shapes and found the resistor value to optimize power. I consider project number 3 to be the grand finale of our experience. Here, researchers are developing a COVID home monitoring system to measure pulse, temperature, and coughing. They are designing flexible biophysical sensors using a material called graphene. Ashley and I were able to help create some of the coughing sensors and test out their performance. It was truly amazing to see this sensor come to existence right before my eyes. Don't let anyone keep you from your dream of being an engineer. If I can do it, you can too. Sometimes you are responsible for independent research, but most of engineering involves collaboration and teamwork. I have brought back several lessons to apply in the classroom so everyone can experience engineering. If you are interested in engineering, consider taking a technology elective, such as robotics or computer science. If your schedule is jam packed and you don't feel like you can fit one of these in your schedule, join our robotics team. Thank you to the National Science Foundation and UConn School of Engineering for sponsoring the Joule Fellows and Da Vinci programs, and to the many individuals who contributed to its success. And special thanks to my lab partner, Ashley LePaine. The Canton Middle School students are lucky to be in your science and engineering classes.